We have a Philips subwoofer. It's a multimedia speaker system model MMS 460/00. The problem with it is it's missing the front grille, but that shouldn't really matter as long as the speaker is okay. The problem with it is it doesn't turn on. Here I have its power supply. When I plug it in, here is the satellite speaker, which features the power button and the volume controls. PS2 connector. We can see that the light on the satellite does not light up. First thing I want to see is whether or not the power supply itself is working. It is supposed to output 16 volts AC. It outputs 16.7 volts AC. So the power supply is working. I'm guessing we are going to have a problem either in the control panel on the satellite speaker or on the main amplifier. So let's dig in. Okay, so on the inside of the box we literally just have a speaker, 4 ohm, 30 watts, decent sized, with a side, and here is our amplifier. And that's nasty. There is a bug leg here and a spider web. Nasty. Anyways, so let's take the amplifier off and try to follow where the power signal is going. Okay, so here is our amplifier. At first glance, nothing looks exploded. This area looks like it has been warm, but that's the primary chip amp, so I would expect that part to get quite hot. Power comes in on this circuit board right here. Okay, so what I'm going to do is I don't feel like taking this part of the circuit out. So what I'm going to do is I'm going to plug the power supply in. I'm assuming that this is the power in because there is a 4-pin package, which is most likely our bridge rectifier, and also these two big pins are likely our primary smoothing capacitor. So let's see if we have anything on the bridge rectifier. We have 1 volt on the bridge rectifier. Am I measuring that correctly? Yes, we have 1.2 volts on the bridge rectifier. And the input of the bridge rectifier goes to this pin, and this goes to this pin. And unless... okay, never mind, we're going to need to take this board out because there is something clearly not right there. Let's trace the voltage again. Here's the power input. Here's the meter, set at 200 volts, like this. And we have 1 volt. Huh. Okay, so we have 16 volts on the connector, but when I plug it in, the other side of the connector is giving us 1 volt. So is the connector bad? Well, what if I do this? Okay, so right now it looks like the connector itself might be bad, or we might have a short circuit and it's the circuit board is shorting the power supply when I plug it back in. Although I would expect to see a spark or something, since I saw nothing. I'm assuming our I'm assuming that just the connector is bad. So what we're going to do is we're going to take some alligator clips, connect that's tricky. Can I connect it? No. Okay, one terminal goes there and one terminal, and the other terminal goes there. And nothing happens. Really, nothing happens. Do I get a spark? No. I don't even get the spark from the power supply. Okay then, what if I feed the amplifier from my bench power supply? I'm going to feed it 24 volts because rectified 16 volt supply will give you around 20 volts, so I think 24 should be good. And might help if I turn on the power supply. Okay, I get the spark and the power supply turns off. And we have power. Okay, so it looks like it's not our subwoofer at fault, it is our power supply. Well, that's interesting. I didn't expect power supply to be a problem because this is an AC transformer. Typically when these fail, they just go open. They don't fail in a way that they they don't really fail in a way that they give out voltage but current drops or some. They don't really fail like this, so that's interesting. Goddamn Phillips and their proprietary screws. Oh, I like how mashing a flathead screwdriver into pretty much any screw can unscrew it. It's literally just an AC transformer and wire. There is not much really to fail. Oh, there is a fuse. Ew, we might have a, oh shit. We might have a blown fuse. Okay. So let's plug it in and see. Turn it on. We have AC 1000 volts, 220 volts on the input, and we have, give it 16 volts on the output, and there is 6 volts on the output of the, I don't think that's true. Well, the best way, the easiest way to test the transformer is just to do this. Yep, we're getting sparks, which means that there is for sure this transformer is healthy. So I'm guessing if we just, this is incredibly sketchy, but if I plug the power supply into the amplifier board, do you see the indicator, and I jump the fuse, yeah, we have power. Well, that was quite easy. I just need to find another what value is this? It's a 5 amp fuse. I believe I can find a 5 amp fuse, although it was kind of weird that I had a half blown fuse. I don't see that happening very often. So, does it have resistance? I was reading voltage. I was reading voltage though. Kilo ohms? Oh. Well, that's a strange way for a fuse to. That's a strange way for a fuse to blow. So it is open, but it has kilo ohms of resistance, and that's why I was reading voltage when I first tested the power supply. And that's pretty much why I started this video. I thought I was going to have to troubleshoot the amplifier board, not the power supply, because the power supply showed correct voltage on the multimeter. Well, that's interesting. Dodgy AliExpress fuses. I need 5 amps. Give me 5 amps. Is it fast 5 amps? Okie dokie. There we are, so a bit of floppy disk cables to extend the cable of the transformer. Put going to the fuse, and from the fuse back to the output, and a heat shrink over all of it. I still don't trust it. I'm going to put some isolation tape. Cables go like this, the switch goes here, and we can cover it up like this. And now, before I fight with these screws again with a flathead screwdriver, I'm going to plug it in, and we have power. That's nice. Okay, so the center channel doesn't work. Left and right works, but the center channel doesn't work. So I guess let's investigate again. That's why you never put things together before testing them.